Thank you, and good afternoon. Yes, I'm going to be talking about mine decarbonization, why it's important for both miners and investors. When I say mine decarbonization, I'm sure a lot of things come to mind. Things like, oh, this is great for our climate change or ESG initiatives, or this is good for reducing our carbon penalties. What I'd like to focus on today, I know all those things are really good, but what I'd like to focus on today is more the financial and risk management strategies that can be accomplished using decarbonization. So let's start and take a look at the mining industry. So the mining industry represents about 4 to 7% of the global footprint. And if you look at what makes up that global footprint, it really comes down to 3 things: diesel, electricity, and process heat. And that's also much the same kind of relationship too when it comes to things like the energy aspect, not just the climate change or the carbon aspect. So a little bit of a breakdown. I think most people in mining would expect to see that diesel's right up there at 45%, and then power about 35%. But I think a lot of people would be surprised about process heat. It's something often we don't think about, but if you take a mine that has a lime kiln or a calcination process, or has roasters, or has dryers, or produces steam, those are all part of that process heat. And that's probably one of the most difficult things to decarbonize as you go through the process of getting to net zero. I'm going to talk about different pathways. Now, obviously, this isn't an exhaustive list, but this is some of the main areas that we can do in terms of decarbonization. Electrification is a big thing. When I say electrification, I'm really talking about material movement. Renewable power, I think most of us see that or expect that in mines. What we don't often see is renewable process heat, and I'll be talking about that today. And then things like energy efficiency and innovation, and finally automation and AI. You have to talk about AI today. If we look at mine electrification, if we look at our friend on the left there, diesel haul trucks, they're the biggest users of diesel. And this is where mines are looking at moving away from diesel and looking towards electrification. And often the first step you see is they use diesel electric trucks. You know, and CAT, Komatsu, all the big miners, all the big players in the marketplace, you know, have diesel electric trucks. They're a little bit more efficient. And what's important here really is the metric that I should have mentioned is when you're talking about material movement, the way to compare apples to apples is using this metric, which is called the energy intensity, and that's measured in kilowatt hours per ton kilometer. Which that means is how much energy does it take to move 1 ton of material or waste 1 kilometer. Obviously, the higher that number is, the less efficient that process is at moving materials. So as I said, if you look at traditional diesel haul trucks, they're almost 0.5 kilowatt hours per ton kilometer. If you go with diesel electric, they're a little bit more efficient because of powertrain efficiencies, regeneration. The engine is running in its sweet spot. Things like that give you a bit better efficiencies. And then you get into more of the electrical technologies, things like electric rail, like railway or conveyors. And they tend to be more efficient. First of all, electrical motors are more efficient than diesel engines. And a lot of times, they're not moving as much mass as you have with the haul truck. If you've been around haul trucks, you know the large size they are, you know the size of their tires, they're carrying their motive power. And you might remember from physics, when you have that kind of mass, that all plays into how much energy it takes to move. If you also look at the energy intensity, you can also calculate what the carbon intensity is of those different material movements, whether it's diesel electric or railway or conveyors. And again, you see our diesel haul trucks have the highest carbon intensity factor as well. And as you move into electric, you'll see those numbers start to drop off. I think this is becoming a pretty standard scenario in mining today, where you see, especially at remote sites, you would see diesel gensets, and those would be augmented with some PV systems. Typically, the PV will provide about 20 to 25% of the electrical needs, and the rest will be accomplished by the diesel gensets. We're seeing mines starting to put into some play into battery storage as well, to try to help to get more of that renewable energy. But again, if you look at this strategy, it's still although it's the right move towards decarbonization, it's still fairly expensive. So if you look at what the weighted average of electricity is for a scenario like this, obviously it depends on what you're paying for diesel and what you're paying for PV power. But kind of a good number to remember is about 25 cents per kilowatt hour. I'm working with a company that is called 247. They have an interesting system. They have a hybrid system that is PV plus CSP plus storage, and that would provide basically 100% of a renewable. And they have the ability to provide backup using fossil fuels if needed for maybe that 10–15% of the time when you've had no sunshine for a while, or it's been rainy or whatever. And that system can also run, if necessary, for that energy that isn't provided by the sun. It can run on diesel, it can run on natural gas, propane, or even hydrogen. And that system would cost about half the price of a diesel plus a PV system. One of the things, I used to be Director of Energy and Climate Change at Barrick Gold, and one of the things that was a challenge for me on our journey to decarbonization was process heat. And in mining, we use process heat for things like rotary dryers, if we have concentrates. We also use it in lime kilns and roasters. And it's interesting, as you start to get low-cost heat available, you can also use it to improve processes like heap leach and electrolyte heating. And I'll be talking about that in just a minute. But basically, this system here is really helpful for doing two things. If you want really high temperature heat to decarbonize your processes and replace your diesel or natural gas or HFO or propane. And it's a CSP system. So it uses heliostats, which captures the solar energy, focuses that into a receiver. It produces about 1,000 degrees C, so about almost 1,800 degrees Fahrenheit. And then you can use that heat for several purposes. You can use that heat to run a turbine, basically a gas turbine where we've taken the combustor out and we're using a high temperature heat exchanger. And so basically, for those who remember their thermodynamics, we're using a Brayton cycle as opposed to most CSP, which uses Rankine cycle. And Rankine cycle has been the traditional methodology where you produce steam, run that steam through a steam turbine and produce power. We don't do that. We run that heat through basically a modified gas turbine and produce electricity that way. And at the same time, you end up producing about 250 degrees C heat that you can also use for processes like rotary dryers. Like 250 degrees C is a really good temperature if you're dealing with copper concentrates and things like that. The other thing you can do is we eliminate the power process of this system, and we use the heat directly. So we can produce about 960 degrees heat, or we can produce 600 degrees C. So 600, 650 degrees C is really better for things like roasters. But if you're doing calcination, 1,000 degrees C is kind of nice. We're also in discussions with smelters who are looking at using our system to do some preheat and sintering, and basically reduce their electrical costs for their smelters. If you get a chance, please stop by B25, because we've only got 20 minutes, so I can't really talk about a lot of things in detail. And if you're interested in some of the stuff I'm talking about, please stop by. What's interesting also is when you have low-cost heat available, you can do some interesting things. Like a lot of mining processes, especially when you have lower quality grade ores, you get into things like heap leach. And one of the things that you can do that's kind of interesting, you can do heap leach heating. And by doing so, you improve the process kinetics. You also reduce the surface tension, and also reduce the viscosity of the solution. And what that does, it means you get the solutions into more crooks and crannies, so to speak, and you're able to liberate more metals that way. In the past, you only really saw heap leach heating in really cold climates. But as I said, if all of a sudden heat is very inexpensive compared to, like most of these places are fairly remote, and if they wanted to do heap leach heating, they would have to use things like diesel boilers to do that. And so now you have the diesel cost to deal with, and you have the carbon footprint. But if you can use this heat to also do heap leach heating, you can greatly improve the recovery of your metals. The same thing can be said for electrolyte heating. If you heat the electrolyte using solar instead of things like diesel or HFO or whatever, there's tremendous energy savings there as well. A lot of mines don't look at this, and they should, and I think this is kind of the thing that you should look at when you're doing your column testing for heap leaches. Really understand what the effect of temperature is on recovery rates, and then start to look at what do the economics look like if I have pretty low-cost heat available to do so. It's the same thing with rotary dryers. When you have this low-cost heat, if you're producing this power, this renewable power, and you want to reduce the amount of moisture in your concentrate, because it's usually a higher value product. You're not transporting water, so your transportation costs are much lower. It's easier for storage and so forth. So it's definitely something to keep in mind as you look at what are some of the strategies you should do at your mine site if you're producing a concentrate or you're using a heap leach. I mentioned in one of the first slides that electricity is one of our big energy users, as well as one of our big carbon emitters. And really, when you look at mining, comminution, basically crushing and grinding, is usually your biggest electrical load. The unfortunate thing in mining is comminution is probably one of the least efficient processes, industrial process out there. Anywhere between 5 and maybe 15% at the most in terms of efficiency. And so you ask, well, where does the rest go? Well, if you look at mills, they're really big heaters and big noisemakers. That's really where most of the energy ends up, not doing useful work. So that's really important. When we're seeing new technologies coming out, like high-pressure grinding rolls and vertical roller mills that are much more efficient than traditional SAG or ball mills. In addition to crushing and grinding, we also have things like better blast optimization and traditional energy management strategies, like variable speed drives, lighting, heat recovery, and so forth. In addition to what we talked about, we're also seeing a lot more efforts on digitization and AI. One of the big ones is ore sorting. Like, instead of processing all the material, really process what makes economical sense. And I guess to kind of put that in perspective, again, it depends on what sensors you're using, and it depends on what type of ore is, but kind of a good rule of thumb is with sorting, you probably get 65% of valuable material and about 35% waste. And finally, simulations and automation. This is also very important to simulate your fleet management process, to really look for optimization. And in the previous discussion, people talked about also automation, like removing the person from the control of the vehicle and really doing that through automation to improve efficiencies and reduce energy and maintenance costs. That's it for today. I guess what I would like to leave you with, though, is I said most times when we talk about decarbonization, we really think about climate change and those environmental aspects. But I think, and those things are very important, but I think it's also important to understand there's a financial and risk management aspect of it. As you saw from some of these slides, we can drastically reduce our energy cost, and energy could represent 30% of your operating costs. So that can make a huge difference in your bottom line. And if you're not having to bring diesel to the site, you're not having to worry about what's the cost of diesel in the future. You're not having to worry about theft. No one likes to talk about it in mining, but there's a lot of theft of diesel. The other things, you don't have to worry about some of the environmental aspects. If you're trucking diesel to the site, what happens if you have a diesel spill? So a lot of the things that I talked about has some of those aspects as well, from a risk management and also a way to reduce operating costs and improve the bottom line at your mine site. So that's why it's important to both miners and investors alike. Thank you.
Thank you very much. We've got time to take one question from the audience. Who would like to ask that question? And please don't make it me. I'm looking at Cal. Surely, Cal, then you'd have a question. I'm going to go and pick on Cal. He's probably going to hate me for it anyway. But Cal, perhaps you can give us a bit of your background and ask a question.
Yes, I'm Cal Bruberg. I'm the CEO of Caro Advisory, and I've worked at Tech for 17 years as their CIO.
Okay.
I'm just wondering, what's your take on SMRs and their viability, given what's happening in China?
Yes.
What's your view of that?
No, I think that's definitely something that is worth, and it's kind of in that sweet spot for mine sites, given the remoteness and the power output from SMRs. I think that's something that you'll see in the future, definitely.
Okay. Thank you very much for that question, Cal. And can we give a warm round of applause once again to Russell Blades, who's a consultant with 24 Solar. Thank you very much for your time.